Welcome everyone to this 10th ALASCA Tech-Talk of this year. For those of you who are here for the first time, just a very brief summary of what we do here. We meet every month at the end of the month, last Friday of the month, and we invite someone to present projects they're working on that are aligned with the objectives of ALASCA, so that have a contribution to digital sovereignty in the cloud, to open source software, to somehow making the cloud more open or more efficient for the rest. So it's a room where we share different ideas on different projects, different technologies, and I'm very happy that you're all here today. My name is Maria, and I'm with Cloud Heat Technologies, who's one of the founding members of ALASCA. And we have a short agenda as usual. We will start right away with today's Tech Talk and discussion. I will briefly introduce our presenter for today and the topic they're going to present, and then, as usual, at the end of the presentation, there will be room for questions, for discussion, for comments on the topics that were presented. And then afterwards, we have some time to share events, news, and well, to discuss any other things that you think might be interesting for the community. So we always prepare some events and news that are interesting from our side, but everyone's welcome to share their news or their events that they think might also be interesting. So if you have anything in mind, or if you want to think about anything you want to share, then please do so. And then I will hand over the microphone to you. Okay, so let's start with today's Tech Talk. We have today Matthias from UhuruTec, who will be presenting the virtual environment that they have developed to develop baremetal provisioning. Matthias is a CEO and founder of UhuruTec, and he has more than 20 years of experience with Unix and Linux, and he's an open source enthusiast. This is a sentence that he said: the computers are just a tool to make human life easier. So sort of a motto, I think. So I will not take more time with this. Matthias, whenever you're ready, you're welcome to start. I will stop my screen sharing now.
Okay, thank you, Maria. Thank you for the introduction. So let's see. Okay, so now you should see the slides. Okay.
Yeah.
I'm talking about today about a virtual environment we developed to make the development of bare metal provisioning easier. And yeah, let's go ahead. Who am I? I'm Matthias, and yeah, as Maria already told you, I'm the CEO and founder of UhuruTec. And there you have my Matrix contact if you want to contact me via Matrix. And what are we doing at UhuruTec? What was the reason why we founded? And yeah, we wanted to make an open source platform, an open source cloud platform based on bare metal, which is also possible to run in smaller scales, but also in large scales, of course. And for this, we are currently working on 3 products, which will all be open source as well, but not yet released because we're still working on that. And it's not the point it's ready to release. So yeah, so the first product is UhuruMetal, or UMetal in short. It's a product which is based on Metal Cubed, so Metal 3 written. This is a cluster API provider for bare metal provisioning. And we are building something around to make the bare metal servers and switches be provided automatically. UhuruStack is the OpenStack which is running on these nodes, which are automatically provisioned or provided and managed. And UhuruStack is based on Yaook, which is, of course, the main part of ALASCA. And yeah, we're also building some parts around that, and yeah, to make it more handy, let's say like that. And the third product we are working on is UhuruFew, which is it's own development of us, because so what we want to do with that is to have a web UI for OpenStack, which is fine and nice and handy, because we see OpenStack Horizon is not it's very old in design, and Skyline is we are not sure about the future of Skyline, so we said, okay, let's make an own development. And furthermore, we want to have an UI which is with which you are able to manage the Uhuru Metal and Uhuru Stack as well, so to see if the infrastructure is running and so on. So, and let's dig in some history, where we came from and why we made this virtual environment. In August 22, Uhuru was released open source, which was a very great point for us, because we had at this time the same idea for some product or for some software to make OpenStack provision via Kubernetes operators. And so we took this and worked on it, and then we saw okay, we need some Kubernetes and bare metal, and we didn't want to have Ansible in our tool chain. Well, as least Ansible as possible, let's say like that, because we want to have everything managed with Kubernetes operators, as if it's possible. And so we started with MetalCube, which is the nearest point, and cluster API was already there. So we took MetalCube and the MetalCube dev-env, which is also a virtual environment to test MetalCube. To understand this MetalCube dev-env was a little bit painful, because it's a wild mix of shell scripts and Ansible, which is really fine for this MetalCube guys, because they have more use or other use cases to test than we need. So our first approach was to extract the main components of their dev-env to make a virtual environment which is simple and usable for us to make this MetalCube running. The result was a virtual environment, which looked similar like this. You had one virtual BMC running in a container, which obviously has always the same IP, and if you have multiple nodes, you will need to run this virtual BMC on different ports, which is not close to real hardware environments. Then further, if you want to control these virtual machines which are running with libvirt, you will have to make a SSH trust from here to the host system, which is not a nice way, I think. It's very it's a little bit sophisticated. We had no redfish in this environment, which is which you need, of course, if you have to do it in a full way. And in the environment, the network part was like, it's always there, you don't have to configure network, it's just running and you don't have to do anything. There's some DHCP running and you don't have to care about IP addresses and so on. And in total, you can say this is a little bit far away from the real world scenario. So if you switch over to a real hardware provisioning, you have to do a lot of stuff afterwards. And this, if you want to develop close to hardware, this doesn't work. So we looked at it and check which requirements we have, and okay, so what we want IPMI and Redfish. We don't only want to, and we want to have this IPMI Redfish running like it's real hardware. So they have the one IP address and different ports for IPMI and Redfish. And and we want the network layer to be managed by us. So we don't want just libvirt network bridges, which are there, but we want some network switch inside. So we want to have virtual network cables to also be able to make use cases like, now let's pull out this cable of the server and what's happening now, and to see what's going on. And then we want to be able to connect nodes via layer 3 to the network switch. So we are running with BGP on it. And we want to have some flexibility for the setup to say, okay, now we have, I don't know, some switches, some servers and so on, and let's put cables from here to there. and see what's going on and how to to make different scenarios possible also. And in total, we want to be as close as possible to real hardware with this environment. And we also wanted to make development scalable, because you see, if you have multiple developers and you want to, everyone wants to develop this bare metal provisioning, you cannot run it all in bare metal. Or at least if you have enough money, okay, maybe that's okay. But the other thing is the virtual environment is also much faster than real hardware. If you boot a server, it takes minutes, and yeah, so this virtual environment is much faster. Yeah, then so the use cases for this virtual environment for us, of course, the development, as I told you right now, and another point is the CI testing. If you have a bare metal provisioning and you want to test it in a CI, you also need some virtual environment which is runnable, or you need a lot of hardware, of course, that's also possible. But virtual environment makes that easier. And if you want to have some trainings and also practice this deployment, it's also fine if you use this virtual environment because it's close to real hardware. So let's have a look at a simple or single layer 2 setup. So we have virtual machines. So we have always this node 00 in our environment, which is our management or provisioning node. For each node, there is some virtual BMC and sushi, which is the redfish interface, running as a process here. And they are running on an IP address and have the regular ports bound, like in the real hardware scenario. So this node 00 is for us always there for our scenario. There might be more if we say our management cluster is multi-node, and we would need more than one node. So, but right now we have a very simple setup here, and makes the understanding also easier. And then we have several nodes, which will be the Kubernetes control plane and worker nodes. And they all have also this virtual BMC and redfish interface. And then we have a virtual switch, which is a sonic virtual switch, which is running a sleeve switch here to make this scenario simple. Okay, so. And now if you put some cables inside, it will look a little bit more, yeah, a little more sophisticated, because, yeah, you see, you have to make these connections, and you have these IP addresses, you have the networks which are running here. Also, we have also word networks here to make routing to outside world possible from the sonic switch, and yeah, and so on. So then you see you can put multiple cables into the servers like in the real world, and this is also configurable. You can say, okay, this server has 10 network interfaces, and this one has 4 interfaces, and this one has 2, and so on. And this, you can decide whatever you want. You can also add more switches, so we can make a leaf spine scenario also if you like, and yeah, then you can see how to configure it, and you can practice this also as well. We were inspired by for the cabling and for this stuff by GNS3, which is also an open source tool for developing or for practicing network layers. For this virtual environment we want, it's not practicable, so because they have a different approach. So we made it a little bit like we took some ideas and put it in another tool we made. So we had some challenges when we developed this, of course. The virtual sonic switch it's nice that it exists, but we didn't find, or it was hard to find ready-built images for that. Especially if you look at the enterprise sonic images, there's only one we found, which was published by Broadcom, and the sonic version of this published image is outdated, so it's a 3.1.2 sonic, enterprise sonic, and community sonic images we didn't found. We found one ready built, but it had no zero touch provisioning inside, so we can do with this later on. The virtual network cables were also part of challenge, because first you have to understand how you can make it, So we made it with UDP unicast tools in libvirt, and ubridge, which is a tool which was developed by the GNS3 guys. ubridge is fine for that, and after you understood, it's running, but ubridge is running either with a static configuration or with API, but you cannot mix it. So that was a point which was challenging, but doable, of course. And performance of this virtual network cables is to be investigated, let's say like that. And network performance, which is also a challenge, which is now better, but still a challenge. We had, when we built it, and then we said, okay, it's running, and tested it, and then we suddenly noticed that some downloads were very slow, so really slow, like 60 kilobit per second, and okay, like in the old times when you had ISDN. And we pointed it to the sonic image, which is bringing down the network performance. Now we have we got some support of Broadcom, which who brought us some offloading settings, which is now better, but it's still not perfect. We don't have gigabit, for example, for this. So this is still running, and So the next steps for us for this virtual environment is to have more setups, like also this layer 3, this BGP and leaf spine architecture, completely to make this running. We also want to try this community sonic and have a closer look at it. We only had a short look at it at community sonic right now, but I think that's the way to go. And the other thing is we want to have it as a virtual network, as virtual environment appliance. So if you want to test in the CI a Kubernetes bare metal deployment with cluster API, you don't want to set up the virtual environment in advance, because this also takes a lot of time. You just want to have an image which is ready with this virtual environment, and just start this image, and then you can directly start with Kubernetes deployment on that environment. Or if you want to have already Kubernetes inside, you can start with some other stuff which is running on that. And so you can have different points where to start. So you can make different appliances and also run them. So now it's time to show this. Let's see. Okay. Now you should see some green text on a black window. Okay. So what I now I have a virtual machine which is running on my laptop, and 1 second, I need to have this big window as well. So okay. This is a virtual machine which is running on my laptop here, which I'm using right now, and I've here checked out this the code or the virtual environment repository, and I already run the preparation of this virtual machine, because we can have a look at that. You have to prepare the virtual machine. You need some tools, some stuff to make this virtual environment running, of course. Until now we have written everything with shell scripts, so that's fastest way to go. It was the fast way to go in one hand, and we have so much interaction with processes, so we decided to use this to make it with shell in the first step. Maybe we'll rework it and to make it to have it in Python, but we'll see. So this is a preparation script which was already running here, and we have image downloading script which was also already running here. So this one is downloading the sonic image, which is public available, and Ubuntu Jammy cloud image to have it for the provisioning. So, and now I will start the setup of the virtual environment. This takes some minutes, and in the meantime we will have a look at the script what is running there. So now let's have a look. So okay, I will scroll to the point where the real stuff starts. So we have this setup. The setup function is where all the interesting stuff is inside here. We need some volume pool for libvirt to have some storage for the virtual machines. Then we need an SSH key to have access to machines which are started here. We need some libvirt networking, which is only a libvirt networking with nothing activated, no DHCP. So it's very simple. Then we need the bridge names. We need some systemd units. So we create a sushi service template and the baseboard management controller service template. So with this stuff here, we will provide the redfish and the IPMI interfaces for the virtual machines. So this is virtual machines, and then we run the ubridge daemon, which is for the cabling. So then next step is to make to have a DNS mask for the zero touch provisioning of Sonic, and then here comes this part of this. So this was all preparation, and now we start. So we make a uplink for the Sonic switch 1 for switch 1 port 9 to the management ubridge of management bridge. So so you put one side of the cable in the switch on port 9, and the other side of the cable you put into the bridge, which is responsible for its management network. And so this is a tab interface in technical, and on the other side it's the switch port connected, and also an uplink for this cluster network. Then we create this node 00, which is our management host. We have got some parameters here, so to make memory configurable, CPUs, the first network. So we have made a decision to have one network interface in this libvirt networks, and we have 2 additional network interface ports. And then we have some storage parameters for this machine, and how we and the bridge where the BMC will be located. Then we start this node, and then we put also some cables here for this node. So say let's make a cable for server 0 port 1 to switch 1 port 10. So then you got a cable plug. Same here. Then we will create the switch as we saw in the picture before. We will give the switch a name, an IP address, and we start up the switch, which is this enterprise Sonic image with version 3.1.2. We prepare everything that zero touch provisioning can run for this switch, and we start a virtual machine, and then we need to get SSH access to this switch. So then finally we will create some virtual machines which are completely empty, so they have only empty volumes like this. So 30 gig volumes, you have 4 of them. So it's like in the real world, you have 4 hard disks with 30 gigabyte, which doesn't exist, of course, but for the virtual environment, it's all fine. And so we make the number of nodes, it's a configurable parameter. So we can say, okay, let's make 6 nodes of this. And for these 6 nodes, we want to be able to make the provisioning. And then we put cables for these nodes also into the switch, which is here made by node ID. So we decided to have the node ID is also the switch port, which makes things easier here, but this is all configurable, of course. Then we created some cables. Then we have to, that's this ubridge thing I told you. If you create this ubridge cable, there will only be one file created, and afterwards we have to configure it to one file, to assemble it to all these files to one file, and restart this ubridge service, and so to make this all work. Then this is the afterwards. There still comes this is stuff for our UMetal environment, which is not part of this talk, and then we will wait until the switch gets accessible, so we can connect it via SSH, and afterwards we also configure this offloading for the networking performance, as I told you before, because yeah, otherwise it will be very slow. And yeah, that's it. So let's have a look. Yeah. So the provisioning is already done. And we'll scroll up to where we started. 1 second. So let's see what happened. Here we started the script. Then the stuff was running. The libvirt networks got created. And then we got this node 00 created. We got the switch created and the other nodes. We also decided we have 6 nodes, I think. Yes, 6 nodes. Then we were waiting to get a switch accessible. Switch was accessible. Okay, fine. Then afterwards we made this offloading settings, as this one is completely from Broadcom support. It's not by us. We just took it and we didn't make it nice, so don't worry. So, and then that's fine. So then we have this virtual environment running now, so we can see. Okay. So, no. Okay. So now you see the virtual machine switch running is now this node 00 and the switch 01, which is our leaf switch, like in the picture we saw before. And now I can access the Sonic switch and say, okay, Sonic switch, show your interfaces. No, show your faces like this. And now you see the Sonic the network switch interfaces. We see this some ports are up, some ports are down, and we have also VLAN configuration on it for layer 2. This scenario is for layer 2 switching. And we have also one node, so let's see if we can put some traffic through this Sonic switch to the outside world. So let's start some TCP dump on Ethernet 9, which is the interface of this node 00. So then let's access this node. So now we are now on node 00, and we try to make a ping to 9999. So the ping is running, but it's not running through the switch. Because the default route is running through this libvirt network. You see, this is management 0 interface is directly connected to libvirt. So let's change this and make the default route going to the other network, which is here, which is connected to the Sonic switch. So we will delete the default route. We set another default route to check if it's there. Yeah, we now have the default route to the 31, and again we start the ping. And we also see the ping in the TCP dump. So we got approved to have this traffic now going through the Sonic switch and can do whatever we want from this point. Okay. I'm running out of time, I know. So, but that's it. I say thank you, and this is the URL for the GitLab repository, which is public now. And if you have questions, in here.
Thank you very much, Matthias. So are there any questions from the audience or comments? You can just unmute yourself and speak, or raise your hand, or post them in the chat. Okay, then maybe a question from my side. Can you make this virtual environment however complex you want to make it, or is there a sort of maximum complexity or size that you can simulate with this?
Well, it depends on the resources you have on where you're running this virtual environment. You know, it's the virtual machines and everything takes CPU and memory usage, and so you're limited to that. But that's the only thing I can imagine right now.
Okay.
Okay, I want to jump in here. Also a question about the sonic switch. Is there some restrictions about the account of ports you can have on the switch, or is it because it's virtual, you can define so many you want?
For the virtual machine, maybe there exists some limits of libvirt, which I don't know. But in general, you can define as many ports as you like. And but the sonic image, the enterprise sonic image, has a limited number of ports. So it's like a real world switch. So yeah.
Okay, good. So it's a definition, or it depends on the software you use. Yeah. Okay.
It depends on the image. We also had a short look at a community sonic image, which was built by for the Azure cloud, which is available for download, which is completely different configured. So they have different lanes behind and different number of ports, like compared to the enterprise image. And yeah, but I think there's a lot of configuration possible.
Okay, thank you.
Okay.
I also have a question.
Great. Yeah, go on.
Do you also use the setup for higher level testing, like setting up VMs, installing Kubernetes, bringing more workload to Kubernetes, and doing all the higher level stuff, or is the purpose only for
short answer
yes. Installation?
Long answer, we also have deploy OpenStack with Yahoo on that, and on this Kubernetes, which is installed afterwards. And we also have a customer who wants to use this virtual environment for their developers to run the higher level stuff on that, and to have a scenario which is as close as possible to the final scenario they will get afterwards. You know, Kubernetes, it's all very great abstracted, but at some point it's good to have a testing environment which is close to the real hardware.
Okay, thanks.
No, you're welcome.
Are there any further questions? Okay, doesn't seem to be the case, but yeah, Matthias, you shared your contact details already, so if there's any questions afterwards, I guess you were open to take them.
Feel free to contact me. I'm open for your questions. Thank you.
Okay, great. Thank you very much for the presentation. And yeah, so now, as I mentioned before, I will just share some news with the rest of you. 1 second. So I hope you're seeing my screen again. These are some of the events and news that we wanted to mention today. Some of them we already mentioned, I think last time, but yeah, so just as a brief reminder, first there's the Sovereign Cloud Stack Community Hackathon that's going to take place in November 8th in Dresden. So I put here the link to the to the website so that you can take a look there. And yeah, we're very happy that ALASCA is also sponsoring this event. Then maybe some of you have seen it, but so there's a quarterly Alaska newsletter, and so the third newsletter is out, and it's published on the Alaska website, and it has a summary of the activities of Alaska in the past months, new projects, new members, and also a quite detailed overview of the development activities that have been taking place in Alaska's project Yauk. So that's something maybe some of you would be interested in reading if you haven't read it yet. And then I just wanted to offer you a brief overview of the upcoming Tech Talks. So in November, we're going to have a talk by Cyberus on building a modern and secure open hypervisor. That's at the 24th of November. Then in December, there will be no Tech Talk because the last Friday of December is very close to Christmas. So that won't be a great time for a Tech Talk. But then we just have a Christmas break. And then we start again in January, 26th of January, with a talk by Daitib on open source multi-cloud resource management console. So those are the Tech Talks that are upcoming in the next month. And yeah, we're working on or we're discussing new topics for the next year too. So if you have any ideas also, that's feel free to contact us. And then one last point that I wanted to ask your collaboration with is that there is a survey that's ongoing on digital dependencies in companies. So it's part of a student project for building a startup, and they're doing some market research and asking companies their perceptions on digital dependencies. So it just takes 5 to 10 minutes, and yeah, it's in English and in German. It's available in both languages. So if you can spare the 5 or 10 minutes, then yeah, we would be very thankful, and the team of students too, I guess. So I'll just paste this link right now in the chat too, so that you can have it. And yeah, otherwise, are there any other news from the community that you want to share with us? As I said, we really want to make this an open platform for exchange. So you feel free to share with us any news or any events that you think might be interesting. Okay, it doesn't seem to be the case. So I'll just proceed. I have to start screen sharing again, sorry. Okay, so I already posted the link in the chat. Yeah, just would be very great if you could spare the 5 to 10 minutes. And otherwise, just not much more to say, just stay tuned. So you know that you can find all the information on the Tech Talks in the Alaska Tech-Talk website. You can also access the past Tech Talks there and watch the YouTube videos that we always upload with the talks in case you miss something. You can also subscribe to the mailing list, and you're getting the invitations every month. So yeah, just take a look there and stay tuned. And otherwise, as I already mentioned, we will have the next Tech Talk on November 24th. It's again the last Friday of the month, again at 11 a.m. as today. And it will be by Cyberus. So we will have Marcos, who will be presenting this topic on the modern and secure hypervisor. So if there are any last comments or questions or something to add, then this would be the time. Otherwise, I thank you very much for joining us today. Thank you especially to Matthias for the presentation. It was very interesting, and yeah, otherwise, I hope that you have a nice month, and I will see you again in a few weeks, hopefully.
Thank you for the possibility.
Thanks.
Okay.
Goodbye. Take
Bye.
care.